This video corresponds with homework 9-2. I'm going to start introducing the concept of the unit circle, which is one of the most foundational, most important pieces of trigonometry. So let's say we have a circle. You guys learned about circles, hopefully in geometry. A circle has the basic format x squared plus y squared equals r squared if it is centered at the origin. And this circle is centered at 0, 0, which is the origin. Now this circle has a radius of 1 unit. So if I were to fill that in for the radius over here on the right, it would be x squared plus y squared equals 1 squared, but 1 squared is 1. So this is the basic equation of the unit circle. It has a center of 0, 0 and a radius of 1 unit. Thus, this whole length here is 1 unit, and this intersects the x-axis at 1 and the y-axis at 1, -1, and -1. Now, let's say I wanted to rotate an angle. So let's say I have my angle in standard position. I'm going to rotate it out or counterclockwise, and I'm going to land here. I'm going to label my point here, x comma y. It lands on that unit circle. I'm going to drop a perpendicular to the x-axis. Now, I don't know exactly the value of this leg along the x-axis, but I do know that it measures x units long, and I know that it's less than 1 because that whole radius, this whole radius equals 1, and I know that it's a little less than that. Now, along the up and down, parallel to the y-axis, I have something that's y units, so this is going to be y. And then I have my hypotenuse, and my hypotenuse happens to be the radius of the circle, and the radius of the circle we know is 1, so that means the hypotenuse is the radius of the circle, which is 1. Now the angle that I rotated is called theta. I'm just going to call it theta for right now in general, okay? So now let's say I wanted to find the sine of angle theta. The sine of angle theta is equal to opposite over hypotenuse. So if I were to do opposite or across from this angle theta, I would have this side here, which I'm just going to call y. Because I don't really know its value, I just know it's going up and down parallel to the y-axis. And then I know the hypotenuse. The hypotenuse is 1 unit. So therefore, the sine of the angle is equal to the y coordinate. The sine is equal to y. Now I'm going to go do the cosine. The cosine of angle theta is going to be adjacent over hypotenuse. Adjacent means next to. So next to is going to be this value here, which is x, over hypotenuse, which is 1 again. So therefore, the cosine of the angle of rotation equals just x, or the x coordinate. Thus, the x coordinate of any point on the unit circle, not just this point in quadrant 1, but any point on the unit circle is equal to the cosine of the angle of rotation, which is right here. And then the y value, or the y coordinate, is equal to the sine of the angle of rotation. So if you have a coordinate pair x comma y, that means that the x is the cosine and the y is the sine. And the song we sing is, sorry, x is cosine, y is sine, on the unit circle, all the time, all the time. So there you go. You're welcome. So now what happens if I rotate this angle into quadrant 2? Well, I could do a reflection actually over this axis, which is the y-axis here, and I'll land my point here in quadrant 2. Now this point's going to be a negative x and a positive y because we're in quadrant 2. And in quadrant 2 we have negative x's and positive y's. So this is going to be my triangle here. Notice that it's perpendicular to the x-axis. Now the angle of rotation here, the whole angle would be in standard position from here all the way around to here. But we can actually use this angle, which I'm going to call R, for the reference angle to help us as well. Now the x coordinate along the x-axis is going to be negative this time because it's going to the left. And then the up and down is still going to be positive. And then the hypotenuse is still going to be 1. So in quadrant 2, the x is negative and the y is positive, which means the cosine is negative and the sine is positive. Now let's rotate our angle or reflect our angle down into quadrant 3. In quadrant 3, my point here will go down to here. And here will be my triangle. Notice the reference angle now will move over to here. And we will have a negative x and a negative y because in quadrant 3, x is negative and y is negative. So therefore, x is cosine, so cosine is negative and sine is negative in quadrant 3. And then in quadrant 4, we can reflect our triangle over the y-axis again. And here's my right angle and here's my reference angle. And then you see that along the x-axis we have a positive x and we have a negative y because it's going down here. Positive x, negative y. And the hypotenuse is still 1 for both of these. So x is positive, so cosine is positive, and sine is negative. So what you need to know about the unit circle is that any point on the unit circle has a cosine of the x coordinate and a sine of the y coordinate. And then the signs, the S-I-G-N-S signs, are going to change depending on what quadrant you're in. So to sum it up, in quadrant 1, we're going to have positive x, positive y. Quadrant 2, negative, positive. Quadrant 3, negative, negative. And quadrant 4, positive, negative. So that means that the cosine and sine, those coordinates correspond, the signs of those values correspond depending on what quadrant we're in. So now let's look at one example here, and then we'll be done. It says the terminal side, so the ending side of the angle in standard position, which means that it starts on the positive side of the x-axis and it rotates around counterclockwise, intersects the unit circle, so it's going to touch the unit circle at this point, okay? So notice we have a negative x and a negative y. Negative x, negative y is going to be in what quadrant? I'm hoping you're saying quadrant 3. All right, so first we need to know that we're in quadrant 3. Now, if we were drawing a triangle in quadrant 3, I'm going to rewrite this. We would want to know that we're intersecting that unit circle, okay? So that means the radius is 1 again, 1, 1, 1, negative 1, negative 1. So the point's going to be somewhere over here, okay? The angle of rotation is going to come from the positive side of the x-axis around to here. It's going to land in quadrant 3. This point has coordinates negative 1/3, comma, negative 8, radical 8 over 3. All right? So now we know that the hypotenuse is equivalent to the radius of the unit circle, which is 1 unit long. And if we had drawn a triangle dropping a perpendicular here, then the x value of the coordinate would be the negative 1/3, and then the y value would be the negative radical 8 over 3, and the hypotenuse would be 1, okay? So if I did Pythagorean theorem on that, I should get 1, all right? Now it's asking to find the secant, all right? So we should know from yesterday that the cosine and the secant are reciprocals. So I can do the cosine of the angle and then I can do the reciprocal. So first I'm going to show you using the triangle. Cosine is equal to adjacent over hypotenuse, which is going to be this. Adjacent to theta here is negative 1/3. And then the hypotenuse is going to be 1. Okay. So that means that the cosine of the angle equals negative 1/3. But now you guys know from above, I said x is cosine, y is sine, y is sine on the unit circle all the time. So that means that because it's a unit circle, all I had to do was look at the x coordinate of my ordered pair, and it is negative 1/3. So that means that the cosine should be the x coordinate, which is negative 1/3 over 1. Now, if I want the secant, I just have to do the reciprocal of the cosine. So if the cosine equals negative 1/3, then the reciprocal is just going to be negative 3 over 1. So the answer is choice 1, negative 3 or negative 3 over 1. If you were looking at the triangle, you would have done hypotenuse over opposite. The hypotenuse is 1. and then the adjacent, sorry, hypotenuse over adjacent, and then the adjacent would have been negative 1/3. So in conclusion, if it states that it's a unit circle, you could either just take the x or y coordinate depending on if it's cosine or sine that you're looking for.